Hi and welcome back. Again, it's been a little while since I've posted a video, and if you saw in my last video, I've been working on a shed extension so that I can move all my wood turning and woodworking gear out there. Here is a photo of the progress. We're up to the stage where we can put the roof rafters on and the roofing on, so that will be the work next weekend. Here is an earlier photo, and it was meant to be an extension on this shed here. But this shed used to be a two-story playhouse for the kids. Then it was dropped down and this little shed was built on top. Now we had to pull that shed down because the floor was not secure. We had to concrete in a few more posts, put in a couple of bearers and a whole bunch of joists to strengthen up the floor. So then we just built everything around that new platform, and this is what it looks like. Alright, back to the video and what we're doing today. This is my parting tool setup for my larger lathe. It's a made in England Eclipse parting tool holder with a parting tool installed here, and it all fits into a quick change tool holder. Now I've got to say, this parting tool is absolutely hopeless. It doesn't cut, and I'm very cautious on how much I wind that hand wheel in on the cross slide, because if it does dig in, then I'm sure it's going to cause some problems. Now, I think the issue is the stick out here. It's a very long stick out, and I think there's probably some flex at the end of the tip, and that is why it doesn't cut into the steel that you're turning. This is my homemade parting tool for my smaller lathe, and I have to say this works absolutely perfect. This was a design from Mark from Winky's workshop. I'll leave a link in the description. Again, it's on a quick change tool holder. The unique thing about this one is it has this hole with a slit in here, and that gives the bottom piece some flexibility when you're cutting. So this gap here will close up when the cutting tool starts to dig in, and that cutting tool will then start moving away from the work, and then you don't get those dig-ins. A really good design, and as I said, this tool works brilliantly. I do have a video on building this parting tool, so I'll leave a link in the description below. So what I want to do is make one of these style tools for my larger lathe. Now it just so happens that recently Mark had done an updated video, and he did a lot of testing on different homemade tools like this and whereabouts that hole and slit are on the tool and how they perform. So he did a whole lot of experimentation, and he worked out the optimum position of that hole and that slit for the tool to work the best. Another thing is Mark provides the plans to build this tool for free on his website. So again, I'll leave a link in the description. The plans are all there. Unfortunately, I'm in metric, but that's not a problem. We can convert these measurements. So again, the full credit goes to Mark, and let's get on with the build. I've sourced all of the parts and materials. This is a BXA tool holder. It's 250-201, and you can see here how much bigger it is compared to an AXA tool holder. Now the materials for the build, for part A, I have this piece of 25 by 12 millimeter steel bar. And for part B, I have this 40 by 10 millimeter steel bar. And for part C, I have this 12 by 7 millimeter steel bar. I need to make this a bit more narrow. It's wider than 12 millimeters. Now, when we get to putting the blade in, I'm going to have to do this a bit different to what Mark's done here. And you can see I did something different on my existing tool holder. The blade I'm using is different to what Mark has, so I will probably have to work out what I need to do here once we get round to that part. I'm starting with part A, and I'm cutting off this piece at the end with a rivet in it, and I move across and cut off a piece slightly longer than what I need. The cut ends are cleaned up in the mill, and this is milled to the correct length. I'm verifying the distance from the front edge here to the centre of the holes. Mark did not have a BXA tool holder, so he wasn't too sure on these measurements. However, his measurements were accurate, and I've noted them all down here in metric, so I'll use that for the next process. The next step is to drill these 8mm holes, so there's 3 of them altogether for mounting onto the tool holder. I deburr the edges of the holes and bolt that onto the tool holder, and that came out pretty good. The next step is to drill and tap these 2 holes here. These will be tapped out to M8 given that most of my hardware is metric. Those holes are drilled out with a 6.8mm drill bit, and I like to start the thread in the milling machine by hand, and then I come back and use the tap wrench to finish off the thread. This is the little slot at the top. The plan has 1/2 inch for this slot, but I'm using a 12mm end mill here. That is pretty much part A complete. So it's got the threaded holes in there, we have a little slot, and we've got our 3 mounting holes on the top. Now I did have a bit of an issue here. That first hole, the bolt wouldn't go down there, and what I discovered is that when I threaded this hole here, the thread or the metal got pushed into the hole a bit. It didn't break through, but it got pushed in there. So I had to run the reamer through there to clear it out, and it still hasn't broken through, but now the bolt fits down there. So perhaps with these measurements here, the second hole probably needs to be moved in another millimetre or so. I start working on part B, which is this 40mm by 10mm steel bar, and I cut a piece off to suit. This is hot rolled steel, and off camera I've tidied it up along the side so that it can fit in the vise properly. I've also used the edge finder and DRO to work out where these mounting holes go, and they're drilled out to 8mm. The hole on the far side is lengthened with an 8mm end mill. The next step is to drill the hole that does the hinge. In Mark's video he mentions that the 3/4 and 7/8 were the best ones. He recommended the 7/8, although his plan still had 3/4 there. Now I've center drilled this, and I'm going to use a 9.5mm drill bit to drill the hole, and I've marked the 7/8 in from the edge of the vise here, and that should work quite good, I think. That hole is drilled out. We get a few fluffy things curling up on the drill bit here, so I need to turn off and clear those off. I screw the 2 parts together. Now I've modified these screws here. They were these countersunk screws, and I've put them in the lathe and flattened off the inside. That makes it a lot narrower so I can get closer to the chuck when I'm parting off. These cap head screws, they stick out a lot further. I don't know if you can see it, but at the top here there is a gap between the 2 pieces, and I think that's because the piece I used on the top was 12mm instead of 1/2 inch, and it is stepped in a little bit from the black part here. So I'm going to have to go and mill that down a little bit so that the top piece is sticking out further than the tool holder. I'll do that later, but now we'll get on with milling the slot for the blade. It's a simple setup here in the mill. I'm using a 12mm cutter, so I have to cut just a little bit wider because it's a 1/2 inch parting tool. And that fits in there nicely. The parting tool goes in the slot, and now we need to be able to retain it. And I'm going to use this design here, a little cap that gets bolted on and pushes on that parting tool. This is 5mm steel bar, and off camera I've already cleaned up the edges so that I can fit it into the vise. And you'll see here that it's only hanging in the vise there by, I don't know, 2mm maybe. So it's a very scary setup, and I'm just taking very light cuts. And I cut this piece out in 2 phases. These are just like 2 thou cuts. Next I need to cut an angle of 3.1 to 3.2 degrees. So again, a bit of a scary setup in the mill. Very light cuts, and all I'm doing here is I'm just cleaning up the surface until it touches the other side, and then that gives us the correct angle. The cap goes on there like that, and you can actually see the taper in the gap, and that's the same taper that we have on our parting tool. That retaining cap needs to be bolted on, and I'm going to use these countersunk bolts. Now I've clamped it up and I'm going to put a tack weld on each side, and that way I can drill and tap all these holes and they'll all line up nice and perfectly. Both holes are drilled out and they're tapped to M6, and then they are countersunk for the screw. Now I'm on the belt grinder. I'm grinding off those 2 tack welds so that I can get the pieces apart again. And it was a bit hard on this side, I couldn't get it apart, but the other side I managed to get it apart, and then that was able to break the other side as well. I've rounded off the edges here and also on this part. Now the parting blade goes in, and there's a little shim I've made up here. This is 0.5 millimeter thick. It goes down the bottom here and it puts more pressure on that blade. That's all screwed together, and then I bolt that onto the other part, or part A. That's almost done. The next step is to cut a little slit in here, and the last part is to make part C, which is a little piece that goes on the top here for adjustment. Now there's a bunch of ways that this little slit can be cut in here. Of course you can use a hacksaw, however Michelle from Rusty Knox would say that would be pretty primitive. I also have a bunch of these slitting saws, but the problem is I don't have any arbors for them, so of course I'd have to go and spend time making an arbor. Another option is to beautiful cut. That's the best option. Alright, we're on to the final part. This is part C. We cut a little piece out. This is the piece I cut out, and it looks a little short. It fits on there quite good, but the thread is going to be right on the edge here, and it will miss the dovetail on the tool holder underneath here. I really need something which is 30 millimeters long, so I'm going to cut another piece out of this bar. This one's cut a little bit longer. I mill down the cut edge to 12 millimeters to fit in the slot. Also clean up both ends. And finally we drill out and tap for M6 bolt. I've rounded around this edge here just for aesthetics. The bolt goes in there like that, and it will sit there, and now the bolt will touch the dovetail on the tool post. So all we need to do now is add some welds in here. The smart ones watching will notice that I'm welding this piece on the wrong way. It should be poking out this other side. And yes, I had to come back with an angle grinder and cut the welds off and re-weld it. That part is all finished, and I have welded this top piece on the right way round now. I have put this together and tested it, and I came up with a bit of the problem with this slotted hole here. When I was using it, this whole plate started to shift backwards. The bolts were fairly tight, but obviously not tight enough. Now those socket head cap screws might be able to be locked down a lot tighter, but I'd rather use my slimline bolts. So what I did in the end there is to rebuild the part again. The only difference here is that it's a round hole, not a slot, and it's in a higher position so that we get the natural angle that we need for the blade here. And the 2 bolts that bolt in here will hold this nice and firmly. Off camera, I'm going to blue some of the parts with a bluing solution to protect them from rusting, and then once I get it all back together, we'll go test it out on the lathe. That is the finished product, and I think it came out really good. I'm very pleased with this. Now, I did blue the tool holder where I milled it down here, so that's nice and black, which is good. I didn't blue the silver bit at the top. I don't know what steel that is, but I've tried to blue it in the past and it doesn't take. But I did blue a couple of the other parts here as well, so looks pretty good. So I've set up the tool height on center with this adjustment here, and that fits onto the tool post like that, and we're ready to go. This is about 25mm steel bar, about 1 inch in diameter. I'm using some cutting oil on a brush, and I'm sort of round the back of the camera, so it's a bit awkward. But anyway, the cutting starts off really well here. I do have quite a slow feed here, so I'll speed this up a little bit and then we'll slow it down once we get to the end. It's always good to go back and put some more oil on the brush as well. And there you go, that's cut off. That was a nice clean cut, so I'm pretty happy with that result. I'm calling this the Spring Cut-Off Tool Mark II, and I use that name because Mark from Winky's workshop invented the tool, and it's the second iteration of the tool that he's made after he did all the testing, so hence the name Mark II. Now I think the angle of the blade here is okay. It's not quite as steep as the angle on my smaller parting tool, but I don't think it's necessary to have the slot in here because you'd probably never have the tool in the horizontal mode. So drilling just a round hole at a different height will give you this natural angle, and that will have no chance of slipping under load. Well, that's another project done, and as I mentioned before, full credit goes to Mark from Winky's workshop. And I do appreciate him sharing the plans with the community, and it's good to be able to build something from a plan, although of course I had to make a couple of changes, but everything turned out good in the end. Once again, thanks for watching.